Hello, this is MEI Further Maths Core Pure. We're in the first complex numbers section and on the sixth and final video on linking complex roots to quadratic equations. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. Have a look at this quadratic equation with real roots. We can solve it by factorising. The mean is 1, and the curve has a vertex at 1 minus 9. Does the mean always give the x-coordinate of the vertex? Have a think about that for quadratic equations with real roots. Let's see what happens for a quadratic equation with complex roots. For practice, pause the video while you solve this by completing the square. OK, completing the square gives z minus 1 all squared, that's z squared minus 2z plus 1, so we'll take off that 1 and then add the 5. Rearranging gives us z minus 1 all squared equals minus 4. So z minus 1 is equal to plus or minus the square root of minus 4. That means that the roots are z equals 1 plus 2i, or z equals 1 minus 2i. Remember that complex roots from a quadratic equation with real coefficients always occur in conjugate pairs, z and z star. And we can choose either of those complex numbers as z, and the other one will be z star. Let's look at this graphically. We have our two roots, 1 plus 2i and 1 minus 2i, and they have a mean of 1. The vertex of this graph is at 1, 4, so again the x-coordinate is the mean of the two roots. This is always going to be true, whether the roots of our quadratic are real or complex. Can you prove this for the general quadratic equation az squared plus bz plus c equals 0? There are more notes on integral on linking complex roots to quadratic equations. That's the end of this short video and the end of this set.